whose hypotenuse is capital R and one of the side is small r. Then what about this height? So if I take here the height of the cone is I'm taking as AB. This is A, this is B, right? So since we know that the volume of the cone whose radius is smaller and the height is small h. Yes, what is the volume of the cone, students? Yes, this is also we can take as capital R. This is radius. Yes, anyone? Volume of the cone.
1/3.
Yes. Let here before that you have to write the matter. Let here you have to write let small r and h be the radius and the height of the cone, right? Circular cone respectively. Then the volume of the cone is V is equal to 1/3 pi r square h. Okay, students, this is the volume. So let us take this is equation 1. Okay, fine. So let us take this is V1. What is the volume of the sphere, students? Anyone? Volume of the sphere. Yes. 4/3. Am I right? See, I want to see here again we're having two variables. We can convert it into a single variable. We have to convert into single variable and we have to prove that. What shall we prove that here? Prove that the volume of the largest cone means we have to finally prove that V1 is equal to 8/27 times of V2. Volume of the cone is equal to 8/27 times of volume of sphere. That we have to prove that finally. So before that, we have to prove that the volume of the cone is maximum. See, the volume of largest cone is maximum. For that, what shall we do? So here two variables are there, two different variables are there. What are that? R and H. We don't have any processor because if you're changing any one of the variable value, the volume of the cone will be changing. If you change the different values of radius, we'll get different volumes. If we give different values of height, we'll get the different volume. So here we can change it to a single variable, like in terms of h alone or in terms of small r alone, your wish. So which is better? Let us see here. So shall I do that? So I want to find this height from, let us take this is center is C. This is A. So what about AC value, Mama? It is a right angle triangle. With help of this, shall I write here height of the cone is given by triangle A. This is some, okay, this is you can take as D. This I'm taking as B. ABC. ABC. Triangle ABC. This ABC is a right angle triangle. So shall I write here BC square hypotenuse square is equal to AB square plus AC square. Yeah, BC means the radius of the sphere, capital R square is equal to AB square. AB is small r, the radius of the cone, small r square plus AC square. We don't know AC value. So AC square is equal to capital R square minus small r square. Remember this, students, AC square. But what is the height of the cone?
That's 2AC.
Yes. Height of the cone is, it's not 2AC. How can you say it is? You see here, both will be same. A from here to here only AC. So height can be written as capital R plus AC. This is the radius of the sphere, capital R, and this is clearly AC. So AC square, we know that from that AC can be written as capital R plus root over capital R square minus small r square. Up to here, is it clear, student? We don't have any procedure to find minimum and maximum for two variables, two different variables. We have a procedure for single variable. So for that, I want to find the small h in terms of small r. Capital R is a constant. Here we have to prove that the volume of cone alone is maximum, not sphere, only cone. For that, I want to convert small h in terms of small r. For that, see here, we got small h value in terms of small r. Smaller. This small h value substitute in equation 1, V1. From 1, the volume of cone is V1 is equal to 1 by 3 pi r square. What is h? Yeah, small h value is capital R plus root over r square minus small r square. Okay, this is h. Now we have to differentiate. Let us take this is equation 3. Differentiate with respect to r. So here UV rule we can apply. This is U. This total is V. UV. This is U. This is U. This total is V. UV rule. Since we know that D of UV formula is UV dash plus U dash V. That's it. So now differentiate equation 3 with respect to R. Okay, all of you differentiate dV1 by dr is equal to 1 by 3 times of pi is a constant. First r square. V dash means, see, the derivative of capital R is 0 because capital R is a constant here. Okay, so we have to just differentiate the radius with which is belongs to cone, not sphere. So capital R is a constant, so that 0 plus it is in the form of root x. What is the derivative of root x? 1 by 2 root x. So 1 by 2 root over capital R square minus small r square into, again the derivative of capital R square is 0 minus small r square is 2r. This is just uv dash plus u dash, small r square derivative is small 2r into capital R plus root over r square minus small r square, whole bracket. So once again uv rule r square, here capital R is a constant 0 0 1 by 2 root of r square minus r square into 0 minus 2r, then u dash is 2r, like that. So after that, so dv by dr 1 by 3 times of pi bracket. Now multiply this r square here. Here, look at here. Here, these two get cancelled. Am I right, students? So what is the remaining value? R square into minus r cube by minus r cube. R square into r minus r cube by root over capital R square small r square plus 2r plus 2r root over r square minus r square. Even if you want, you can take LCM. All of you take LCM here. Okay. 1 by 3 pi then minus, take LCM. What is the LCM? Root over r square capital R square minus small r square. So here minus r cube plus 2 pi capital, so is it 2 r into capital R? 2 r capital R root over r square minus small r square plus 2 r to capital R square minus small r square. Yes, student, all of you simplify this. Yes. When I multiply with 1 by 3 pi here anyhow, 2 r cube will get 1 by 3 pi times of, because you know this is just a first derivative. Once again we have to differentiate this. So 2r capital R root over capital R square minus small r square. Yeah, when I multiply this 2r capital R square minus 2r cube. Yeah, first one is minus r cube. This is first term I have written at last by root over r square minus small r square. So what about this last minus 2 minus 3 r cube will get minus 3 r cube. Okay, students. Then next, yes. Finally, what is dv by dr? We may write like this also, like so dv by dr is equal to, when I multiply here and write it separately, so this get cancelled, 2 by 3 pi, then get cancelled, r capital R. Okay, students. Plus when I combine these two, so here we are going to get plus, when I multiply this, 2 pi r capital R square minus, multiply with this pi, 3 pi r cube by root over 3 times of capital R square minus small r square. Is it clear, student? From above step I have written this. Is it clear? Yes, absolutely right. Clear? I differentiated this equation 3 with respect to r. Finally, we got this. This is equation 4. So what shall we do for critical point? For maxima minima, this is dv by dr equating to 0. When I equating to 0, yes, students, when I equating to 0, what is the r value we are going to get? That is important. So 2 by 3 pi r capital R is equal to this value. When I equating to 0, this total value. The second value you have to take right side. Okay, ma? And minus of this 2 pi common. What is the common here? You can take common is pi r, small pi r, small r you can common. So this is 2 pi pi already I'm taking common, 2 capital R square minus 3 r square, 3 small r square by 3 times of root over capital R square minus small r square. Can you tell me what is the critical point here? Critical point in the sense smaller value. We have to find smaller value. Anything will be cancelled? Yes, it will be cancelled. Pi get cancelled. Small r get cancelled.
Sir, can you scroll up a little, sir?
Yeah.
Okay, sir.
Yes, friends, after that, cross multiply this. Here 3, 3 also get cancelled. 3, 3. What is the remaining value? Just 2 into capital R. When I cross multiply here, this is capital R square minus small r square. It is equal to right side is when I multiply with minus 3r square minus 2 capital R square. Clear? So here square root will be there. Square root means we can squaring on both sides. When I squaring on both side here, right. See here, just I found only first derivative. We need to find the second derivative also. So 4r square into r square minus small r square is equal to a minus b whole square. 9r to the power of 4 plus 4r to the power of 4 minus 2 into 6, 2 into 3, 6, 6 into 2, 12, r square, r square. So all values you can take at one side, smaller values. So this is 4r to the power of 4 minus 4 r square small r square minus into minus plus 12 r square capital R square minus 9 r to the power of 4 is equal to 4 r to the power of 4. Okay, students, what shall we cancel here? Shall I cancel this 2? Yes. Then what is the common here? Here 9 r power 4. What about these two? Shall I write plus 8 r square capital R square? So what is the common should I take? Shall I take minus r square is common? Yes. 9 r square minus 8 capital R square is equal to 0. One of the value R value is 0 because minus R square is equal to 0. Another value is 9 R square minus 8 capital R square is equal to 0. From that, what is small r square value? 8 r square by 9. So 8 by 9 r square. So what about this 8 9 by r square? It is r small r square value. Finally, we got the critical point. R is equal to, okay, we can write 2 root 2 capital R by 3. We can write any one of the value. So at this critical point, we have to check the second derivative. These students very carefully have to do. So what I have done, I have taken the graph of that sphere and cone. So I have written V1 and V2, volume of the cone and volume of the sphere. So with this, okay, radius of the sphere, they have given capital R, and radius of the cone I'm taking, let us consider small r is the radius, height is h. So here clearly h is equal to can be written as capital R plus AC. So I want to find AC with help of the right angle triangle. So AC value in terms of small r we get like in terms of capital R small r. So AC square is equal to capital R square minus small r square. So from that AC is equal to square root over r square minus r square. So this is h value. Final height is equal to r plus this value. This value I substituted in V1 because we have to prove that the volume of the cone is maximum, greatest volume. So for that, I change it to single variable in terms of smaller. Now I have to differentiate with respect to smaller by using UV rule. Okay, UV rule, and after finding the first derivative, I equating to 0. So when I equating to 0, we got the critical point. The critical point is 2 root 2 capital R by 3. This is the critical point. So at this critical point, we have to check the second derivative, that is d square v by dx square. For that, what shall we do? dv by dr I want to take first. What is dv by dr? Equation 4. Two by 3 by r.
Sir, you can score it up, sir.
Sure. And 2 pi's or capital R square minus 3 pi capital R cube small r cube or capital R cube small r cube all divided by 3 into root over r square. Right, this is dv by dr. Am I right, students? Everything is clear? 2 pi, because the first derivative is correct, then only the second derivative becomes again differentiate. Okay, again whenever we'll differentiate again. So here clearly d square v by dr square is equal to, with respect to our capital R, everything is constant. So 2 by 3 pi, what is small r value? 1 into capital R. This is okay, but the second one is, it is in the form of u by v rule. This is u, this is v. Fine. So now, what is the derivative of u by v rule, Amma? D of u by v is equal to v u dash minus u v dash by v square. With help of this, first v u dash 3 into root over r square minus small r square. This is v. U dash means numerator derivative. 2 pi small r value is 1 into capital R square minus 3 pi into r cube derivative is 3r square. Okay. Minus, yes, students, minus v u dash means 2 pi r capital R square minus 3 pi cap small r cube into the derivative of denominator means 3 into 1 by 2 root over capital R square minus small r square. Again the derivative of capital R square 0 minus 2r. All divided by 3 into root over capital R square minus small r square, the whole square by v square. V u dash minus u v dash by v square, just I applied that. So d square v by dr square is equal to, so 2 by 3 pi capital R plus, yeah, here it is, denominator is 9 capital R square minus small r square. Okay, students, here now 3 into root over capital R square minus small r square bracket. So 2 pi capital R square minus 9 pi r square. Okay, now minus, minus to minus plus, am I right? See, students, here minus is there, here minus is there, minus to minus plus, plus. So what about this value, ma? 2 pi r capital R square minus 3 pi small r cube into here 6r into 6r by, see, 3 to the 6r by, okay, 2 you can cancel, it's better to cancel 2, then it will becomes 3r by root over r square minus small r square. Yeah, we'll do one thing, you can take LCM here. What is the LCM? Numerator root over r square minus r square. When I take LCM here, nine r square minus small r square. The LCM in numerator clearly root over r square minus small r square. So when I take LCM here, 3 times of capital R square minus small r square will get into 2 pi capital R square minus 9 pi small r square plus the remaining is 3r into 2 pi r capital R square minus 3 pi r cube. Okay, this is finally. So is it clear? Now you can multiply all this numerator. So denominator,
Can you scroll up, sir?
why not? I'll share you this slide.
Okay, sir.
Okay, students, see here after this, it is quite, again, it will take more time. It's not required. Just what shall we do? A second derivative. Second derivative, I want to substitute capital R square. What is the capital R square? Small r square. Small r square is equal to 8 capital R square by 9. At that point, we need to check here. In every, okay, when I multiply here r, shall I multiply this r here inside? When I multiply this small r, we are going to get square whole power 4. Right. Now, we have to check this value at the critical point.
Sir, you can scroll a little up, sir.
Yeah, substitute all of you here this r square value at this critical point. Check the second derivative. So d square v by v1 by dr square is equal to, at this point, so 2 by 3 pi r. This is clearly greater than 0. And 3 into capital R square minus small r square means 8 by 9 capital R square into 2 pi capital R square minus 9 pi small r means 8 by 9 capital R square, 8 by 9. Okay, students? Bracket plus 3 times of 2 pi r square, 8 by 9 capital R square into capital R minus 3 pi r power 4. R power 4 means 8 by 9 r square, the whole square, by, this is here, it is in the, let us take, this is x, this is root x, nothing but x power 3 by 2. Am I right? We can write like this. So here 9 times of square root of r square, not square root, all to the power of, will take 3 by 2. Capital R square minus 8 by 9 small r square, sorry, small r square value, all power 3 by 2. See here, d square v by dr square is clearly equal to 2 by 3 pi r capital R, 2 by 3 pi capital R plus. So what about this value, Amma? 9r square. When I take LCM, 9r square minus 8r square, just r square. So here 3 get cancelled. So r square by 3, that's all, into, so what about here, 9 get cancelled. 2 pi r square minus 8 pi r square, that is minus 6 pi r square, plus 3 times of. So what about here? Here also same, r cube, here r power 4. Okay, so anyhow, What is the value we are getting here? 8 to the 16. Here 8 square 64 threes are 192 r per 4 by 81 pi. So after that 9 into capital R square by 9 whole power 3 by 2. Because when I take LCM, 9r square minus 8r square is just r square whole power 3 by 2. So what shall we prove that, students, here? What shall we prove? Minimum or maximum in the question? Yes, largest. Largest means maximum. Volume is largest means maximum means what shall we prove that second derivative? Is it lesser than 0 or greater than 0? And no need to simplify all this. This is very lengthy again. Simply can write it is lesser than 0. Therefore, by second derivative test, the volume of cone is maximum. That's all. Okay, maximum fine. Just 2 minutes, I'll be finish it. So what about that maximum? What shall we prove that? So it is 8 by 27 of 27, right? So this r square value, h value, I want to substitute in V1. Okay, what is HM? See here. I want to take equation 1. In equation 1, capital R square, already we got it. Just we have to find h value. H value is what? Capital R plus, what is h value here? Capital R plus, yes. So already we got small r square. Small r square you can substitute here in this case, smaller. So this is small. H is clearly equal to capital R plus root over.
The previous step also.
Yes, sure. So this is equal to, see here, capital R plus root over capital R square minus what is small r square? 8 by 9 capital R square. So this is equal to capital R plus root over R square by 9 will get. R square by 9 nothing but small h is equal to capital R plus capital R or capital R square? Capital R only. So R by 3 will get. So that is nothing but 4R by 3. So final h value is 4R by 3. R square value is 8 by 9 R square. This value you can substitute in V1. So V1 is equal to 4 by 3. Sorry. What is the volume of cone? 1 by 3 pi R square H. 1 by 3 pi R square. Small r square is 8 by 9 capital R square. What is small h value we got? 4R by 3 we got. Because sphere volume already we have written in terms of capital R. Where is that? Yeah, here. 4 by 3 pi R cube. So now 4 by 3 pi R cube. So this is clearly equal to 8 by 27. This 8 I want to take outside. By 27 I want to write here because this is 3 9s 27. So remaining value I want to write in the bracket. What is the remaining value here? Remaining value here 4 by 3 is there. So 4 by 3 pi. Pi is there, pi. Capital R square into capital R cube. Then what about this sum from equation? Sorry. Yes, what about this? What do you observe? V2. This is clearly V2. So V1 V1 is equal to 8 by 27 times of V2. We proved or not? Yes, we proved. This question alone you can try to practice thrice or 3 times or 4 times. Okay. Even next question also. This is the only question very lengthy in the Maxima. Is it clear, Amma? Having any doubts, you can ask. Otherwise, you can leave the meeting.
You can show the presentation.